Hi class, and welcome to another video lesson. This is problem number 2 on our notes for today, which is the linear programming notes. If you have not done number 2 on your own just yet, I want you to pause the video. Go watch video number 1, which is on Bryn being a vet. Watch that one first, and then try number 2 on your own. Once you are done trying number 2 on your own, then I want you to watch this video and to check over your work. So if you have not done number 2 yet, please stop the video and try to do number 2 on your own. Alright, so now that you've tried number 2 on your own, I hope that everything that you're reading makes sense to you. Ethan wants to make as much money possible in one day. He does 2 different things, his company does, I guess. He mows lawns and he prunes bushes. So those 2 things, prune shrubbery I guess is what I should say. Those 2 things is what he's going to do to make money. He makes $40 an hour for mowing lawns, and he makes $120 an hour for pruning shrubbery. And so with this, he wants to make as much money as possible. So as we define our variables, hopefully you guys can see on your graph paper that I've given you in the notes, it says what the x variable and what the y variable is. It says the x variable is mowing jobs. It says something like mowing jobs over here. And here it is pruning on the y variable. So that's what we're going to define our variables as. X is the mowing jobs, and the y variable is going to be the pruning jobs. Alright, so step number 1 is done. Next one is write a system of inequalities and graph that system. This is, like I said in video for problem number 1, is the most difficult part in my opinion. Just going to move this down to give us a little more room. Alright. Like I said with problem number 1, there's no such thing as doing a negative number of jobs. That's just impossible. Just like in this one, you can't do a negative number of mowing jobs. The very lowest you can do is you can mow 0 lawns. Or as far as pruning shrubbery is concerned, the very lowest you can do is 0. So that means x has to be greater than or equal to 0, and y has to be greater than or equal to 0. So what's that saying? It's saying that your bounded region is going to be somewhere in this first quadrant. Because if x is greater than or equal to 0, it's going to be everything. Let's see, an x equals line is vertical, so it's going to be everything right in here. And a y equals line, y is greater than or equal to 0, is going to be everything also up in here. So we know that it has to be in the first quadrant. That's where our bounded region is going to be. So with that being said, we have two more equations that we have to find somewhere in this area. One, hopefully you can see, is right here. Each crew is scheduled for no more than 2 pruning jobs per day. They can't do 3 pruning jobs a day. They can do 0, they can do 1, or they can do 2. So if they can do 2 or less than that, that means that pruning, which is our y variable, it has to be less than or equal to 2. You could do 2, 1, or 0 pruning jobs. So a y equals line is a horizontal line. It's at 2. So there it is. And it's going to be everything less than. So I'm not going to shade it just yet. I'm going to shade it at the end. But know that it's going to be everything right in here. Y is less than or equal to 2. It's everything below that line. Alright, and now there is one more. It says that the company schedules 1 hour for mowing jobs. So if they do 1 mowing job, it takes 1 hour. If they do 5 mowing jobs, it takes 5 hours. Whatever the case might be, mowing is the x variable. So 5 times the amount of jobs, 5 times 1, or 5 times 3, or whatever. Sorry, not 5. It takes 1 hour. That was my fault, class. Sorry about that. 1 multiplied by 1, or if it takes 5 hours, 1 times 5, or if it takes 7 hours, 1 times 7, so on and so forth. If they do 7 jobs, 1 hour times 7, 7 hours. So it's going to be 1 times x or just x. Likewise, for pruning jobs, that takes quite a bit longer. It takes 3 hours for those pruning jobs. So if they do 2 pruning jobs, 2 times 3 is 6. If they do 4 pruning jobs, 4 times 3 is 12. Whatever. Oh, they can't do 4. You guys know what I mean. However many jobs they do, you have to multiply it by 3. So it's going to be 3y. Now, the amount of hours that they work in a day cannot go more than 9. The maximum hours that this schedule is set up for is 9 hours. So I know with a combination of their mowing and their pruning that it has to be less than or equal to 9. They can work 9. It can be equal to 9, but it cannot be anything greater than 9. It has to be less than. So this is your fourth and final equation. Here's 1, here's your second, here's 3, and here's your fourth and final equation. So, we're now going to graph this one. So if I were to put this into y equals mx plus b form, I would subtract an x right here. 3y is less than or equal to a negative x plus 9. Divide both sides by 3. Y is less than or equal to a negative 1/3 x plus 3. So it has a y-intercept of 3. 1, 2, 3. And then my slope is a negative 1/3. So down 1, right, 1, 2, 3. Down 1, right, 1, 2, 3. Down 1, right, 1, 2, 3. Okay, I will connect these dots with a straight line. I encourage you to use a straight edge. I'm just going to guesstimate here, but I encourage you to use a straight edge. And then it says that it is everything less than, which is everything below the line. So now remember, it's going to be in the first quadrant, so it's going to be everything in here. Now it has to be less than 2, so it has to be less than the green line and less than the blue line. So now it's going to be everything that is right in here. This is your shaded region. This is what I want you to put very, very, very dark on your notes, class. So you have that trapezoidal figure. That's going to be your bounded region. All right, our next step is to label our vertices. So our vertices, I think they're pretty clear on this one. One of them is 0, 0. Next one is right here. That's at 0, 2. Third one, we'll go right here. This one is 9. It's right 9, 0. And then the last one is right here. That is right 3 up 2. Right 3 up 2. All right, our next step. Let's write a function to be maximized or minimized. He wants to maximize his profit, so don't worry about this minimize one. We want to write a function to be maximized. So if he does 1 mowing job, he makes 40 bucks. If he does 2 mowing jobs, he makes 80, 3, 120, 4, 160. However many mowing jobs he does, let's multiply it by 40. So it is 40 times the number of mowing jobs, which our mowing variable is x. Likewise, 120 for pruning jobs. So if he does 1 pruning job, he makes 120. And every other time, you're going to multiply it by 120. So 120 multiplied by our pruning variable, which our pruning variable is y. So this is our function to be maximized. So I'm going to put that right here in my chart. 40x plus 120 times y. All right, the rest is pretty simple. Let's just put in our values. Let's substitute them into this function. So we have 40 multiplied by 0 plus 120 multiplied by 0. Obviously, if he does 0 mowing jobs and 0 pruning jobs, he's taking a day off and he gets $0 that day. If he only does pruning jobs, 40 times 0 plus 120 times 2. If he decides, you know what, we're not going to do any mowing jobs today, we're only going to do pruning jobs, and only 2 of them, he would make $240 that day. All right, next one. This time he decides, you know what, mowing is where it's at. We're going to do 9 of those mowing jobs. We're going to fill our day. And we're not going to do any pruning jobs. 40 times 9, that's going to be $360. So he's better off doing only mowing jobs and no pruning jobs than he is doing only pruning jobs and no mowing jobs. Let's see what happens with this combination. He does 3 mowing jobs, 40 times 3. Plus, he does his 2 pruning jobs that his schedule allows, 120 times 2. 40 times 3 is 120. 120 times 2 is 240. 120 plus 240 is 360. So let's select the greatest or least to answer the question. And in this one, he wants to maximize, so let's pick the greatest. As you can see, Ethan has some options here, doesn't he? He can do either one of these, and that would maximize his profit. So we could say, select, and I want you to write a little sentence that explains to me that you know what you're doing. You can say, Ethan can do 9 mowing jobs and 0 pruning jobs, or he can do 3 mowing jobs and 2 pruning jobs. Either way, he will make, how much was that again? $360. So this is another one that Ethan can look at. Maybe it doesn't take as many people to do the mowing as it does compared to the pruning. In that case, he would want to do all mowing jobs and then no pruning jobs. However, maybe he thinks that pruning is easier than mowing. This is only 5 jobs, where this is a total of 9 jobs. Maybe he'd want to do this one instead. Maybe it changes from day to day. Maybe one of his crews likes consistency. In that case, they would want to do these 9 jobs over and over and over again because they're good at it. Maybe another one of his crews likes a little bit of variety. In that case, they'd want to do a little bit of both. They'd want some pruning and some mowing. So it all depends on, I guess, the personnel that you have and what your interests are. So that's a real-world situation that you might need to use linear programming. We'll have more example problems in class. We also have a worksheet on this, so make sure that you are concentrating on your worksheet. The biggest part here is to read the question, and not only read it, but understand it, and kind of put a little bit of thought into the process of what goes into with these linear programming questions. So be sure to let me know if you have any questions on these as well.